Hi everyone. Today we're going to be talking about the line of best fit. So this pairs up with what we had last week, which was scatter plots. Alright, so let's go on to the next slide. Now one of the things you can do to make this screen a little bit bigger is you can come down here to this bar and you can drag that down, and that'll make that just a little bit bigger to help us out. Alright, so let's go to our next slide. So line of best fit helps us make interpretations and predictions about a situation involved in the data set. Most real data does not fall perfectly on a line. However, if the data on a scatter plot resembles a line, we can fit a line to the data. We can write a function for the line and use this function to solve problems and make predictions. The line we use to represent the data is called the line of best fit. We will refer to the function you write for the line of best fit as a prediction function. The most common way to find the line of best fit is to use the eyeballing technique. Simply draw a straight line that best fits the data. Alright, so let's go ahead and give it a try. So in example 1, we're going to observe the data set and take notes of any associations we might see. We're going to draw a line of best fit, we're going to write a prediction function, and we're going to use our function to predict the value of y when x equals 12 and when x equals 100. Alright, let's first make some observations. So we're going to actually click in here. We're going to come in and we are going to see what kind of predictions or observations that we can make. So observations that I notice are that it looks like it has a positive trend. So I'm going to type that in. Hopefully I can spell it right. So it has a positive trend. Right? Are there any other observations that we might make? Maybe that it has a y-intercept really close to 2. So if we notice this point right here is really close to the 2. It's not quite there, but it's really close. Right? So as a positive trend, the points are really close to making a straight line. Okay, so points are close to making a line. Alright, so now what we're going to do is we're going to actually draw in our line of best fit. So I'm going to take this little thing up here and I'm going to draw in my line. So when we draw a line, we want about half of our data on each side of that line, as best as we can. So I'm going to draw in a line as best as I can. I may go through some points, and I may not, right? And that's okay. We want to try and just get it so that we've got about half of our data on either side of that line. So there's my line. Now what I'm going to do is, because I want to make it darker, and I'm probably going to make it stick out, I'm going to make my line red. And then I'm going to make it 3 points. That way it'll stick out a little bit better. So now we can see our line. You can see about half of the data, like our line does go through some set points, right? And then we've got some points that are not exactly touching the line. Right? So now we're going to estimate the slope and the y-intercept of our line. So let's talk about the slope. So I see 2 points that actually appear like they're actually right on that line. So I'm going to use those 2 points, because those 2 points are almost centered right on the line. So this point appears to be at about 1, 3, and this one appears to be about 3, 5. And when we're doing these line of best fits, everything's going to be kind of close. We're going to do the best that we can. So my slope is going to be, I'm going to go up 2 over 2. So it almost looks like my slope is 1. So up 2 over 2, 2 over 2 is 1. So I can come in here, click in here, my slope is 1. Right, my y-intercept, well, my y-intercept looks to be about 2. So I'm going to put 2. So now remember, when we go to write a line of best fit, our function, if we remember, the form of the equation that we talked about last week was y equals mx plus b. M is our slope, b is our y-intercept. So my actual equation is going to be y equals, my m, we said was 1. At My b, we said was 2. It's a positive 2. So there's my equation. Y equals 1x plus 2. All right, so now we're going to use that equation that we just came up with to make a prediction. So use the line of best fit to find the value, I should say, of x. I'll make sure that that's fixed on yours. When x equals, or not x, or y, when x equals 12. So what does y equal? All right, well, y is going to equal 1 times 12 plus 2. So what does that equal? So that means y is going to equal 14. So when x is 12, that's off of our thing here, y should be somewhere up here. Should be about 14. And that's what we're looking for. All right, well, what if x is 100? What would y equal? So we're going to take our equation, y times, or 1 times 100, and we said plus 2. So we're going to come over here, so do the math. What does y equal? 1 times 100 is 100, plus 2, so 102. Alright, so what do you guys think? That wasn't so bad. Alright, let's come down and try another problem. Alright, let's make some observations here. So in this case, some observations that I might make is that it has a negative trend. I might observe that the y-intercept is really close to 8. Let's see, anything else? Again, those points are fairly close together. Alright, well, let's try and make our line. So I'm going to start with my line right about here, and I'm going to just kind of draw it through, and I'm going to kind of move my line back and forth until I feel like I've got it kind of through the middle of my data, but I'm really going through about the data points on each cell. So that looks good, and I really liked the color red, and I'm going to make that 3 point again, just to make it stick out. Okay, so now I've got my line. So now let's estimate our slope. So I'm looking at where my line is crossing blue points, and again it looks like I'm hitting every intersection as I go over. So I go down 1, over 1, down 1, over 1. Looks like that's going to follow the same pattern, down 1, over 1 every time. So my slope appears to be about a negative 1. My y-intercept is about 8. Alright, well, let's write our equation. So again, remember, our equation is in the form of y equals mx plus b. So my equation itself, then, y equals, my m was negative 1, and my y-intercept, we said, was 8. Alright, so let's use that equation there to predict. So what would y be when x is 15? Well, we had negative 1 times the x value of 15 plus 8. So we could say then that y is going to equal, so we have negative 15 plus 8 gives me negative 7. And then we can try again what happens when x is 20. So I've got negative 1 times 20, and again, plus 8. So now I'm going to have negative 20 plus 8 gives me negative 12. Okay. Well, that wasn't so bad. And let's take a look at another example. Let's do this one more time. So Camilo and his family are taking a road trip. The graph below shows the total distance the family traveled over an 8-hour period. All right, so estimate the slope and y-intercept of the line. All right, well, let's draw on the line. It's the best way to do it. So it looks like I have a point directly at 0, 0. So we're going to definitely start our line right there. And then I'm going to stretch my line out through, trying to make my points kind of spread out on either side as best as I can. So I might make it kind of like that. That looks fairly decent. And again, I liked red. You can make yours whatever color you want in 3-point. Alright, I'm going to take a look at my line. Do I like it? You know what, I might shift it over just a little bit. I think I'm going to like it this way a little bit better. Okay, so again, we're kind of eyeballing. It's kind of hard to tell because now I have 3. And maybe I will shift it back this way just a wee bit. Alright. So now we can go ahead and we can estimate. So our slope. So it looks like I'm going up 60 over 1. Up 60. So we have to pay attention to that y-axis and how they're numbered. So each line is worth 30. So if I went from here to here, that was up going up 60 and then over 1. And then up 60 over 1. So it looks like my slope in this case is 60. My y-intercept is 0. Right, well, let's write our function again. So it was y equals mx plus b. So my y equals 60x. Since my b is 0, I don't have to put the plus 0. I don't need to. So I can just leave it like that. Alright, so what is the slope in this representing? So remember, this is my distance in miles over time in hours. So what is the slope representing in this context? It's my miles over hours. So in this case, I would say slope is representing the speed. And we say miles per hour. That's exactly what our slope was. It was the number of miles over the number of hours. What does the y-intercept represent in this context? All right, well, that was probably like right when we got in the car. So the point right before the trip started. The point at which the trip started. That would be my interpretation of that. Alright, let's try another example. Which equation best represents the line of best fit? So now we're going to notice we have some decimals going on, and we're just trying to kind of eyeball which one is going to be the best. I'm going to start with the y-intercept. So I see that right here is the number 1, right here is the number 2. So this appears to be falling right halfway between 1 and 2. So that means that my slope is about 1.5. Right? About 1.5. Well, you know what that means? That means I can eliminate this one, because this has a y-intercept of 1.9, and I could probably eliminate this one as well. So I'm going to eliminate those two. So 1.4, 1.5, those are all pretty close. So now we have to check, is our slope closer to 1, or is our slope closer to 2? So when we start here, so let's see, every 2 lines means I'm going up 1. And then every 2 lines across means I'm going up 1. Alright, so let's see how this works. So I'm going to say we start at the halfway point. And let's see, if I go up to the halfway point, over to the halfway, over 1. So if I go up, and then over, I would say our slope is really close to 1. So each time I had to go up 2 lines, over 2 lines, up 2 lines, over 2 lines. And that would get me pretty close to my line. So I'm going to go with, I don't think I can actually draw this. We'll see. I can make class. So I'm going to say that this guy here is my answer. What happened? All right, let's see. We can format this. So to do that, so to format this, because we want that to show up, okay, I am going to come over and format. And let's see. We cannot do it that. I forgot how I did this. Forgot how I managed to make this work. Fill, oh, transparent. There we go. That's how I did it. So I did fill color, and then I made it transparent. And you know what? I'm just going to make my border color red, and really make it stick out. There's my answer. Alright, so why did we pick this one? Well, first we identified that our y-intercept was really close to 1.5. It's exactly halfway between 1 and 2. So that left us with 1.4 or 1.5. Then we had to decide, was our slope closer to 1 or was it closer to 2? We had to pay attention to what each grid line represented. Each grid line represented half a move. So to go up 1, I really had to go up 2 grid lines. And to go over 1, I again had to go over 2 grid lines. So to get from one point to the next, I really had to go up 2 grid lines, over 2 grid lines. So that really meant go up 1, over 1. So up 2 grid lines, over 2 grid lines, got me really close. So again, 2 grid lines represented a move of 1. Alright, so that meant our slope was really close to 1. Alright, well that is it for our notes. I hope you like doing these on the Google Slides again. So please make sure that you do get those complete. Try the practice problems, and I will see you in class.